Okay, here we go. We're going to be doing writing equations of lines practice test. And as you can see, there are 6 categories in this practice test, just like they will be on the test. So I'm going to run through this pretty quickly because this is old stuff and we're pretty good at it by now. When we see a line like this where we can clearly see the y-intercept, we know we're going to be using the y equals mx plus b, the slope-intercept form. And we see that our b is 2, our slope-intercept is 2. And we see once we find 2 corner points, it looks like a corner point, that our slope is down 2 over 3. So our slope is going to be 2 over 3, except for, wait a minute, if I write my name on this line, it's going downhill, so that's a negative 2/3. So all you have to do on this problem is plug the slope in, plug the y-intercept in, and you are good to go. Problem number 2, write the equation of the line graph below in slope-intercept form. So we look at it, and of course, oh, why? Can you see my arms out? Oh, why does y equal negative 7 look like this? That's all it takes. Okay, the next one, if y is a horizontal line, then we know x is a vertical line. So this goes through negative 7 on the x-axis. So this is x equals negative 7. If I'm going too fast for you, please go ahead and pause it. This video is going to be long if I take my time, so I'm going to try to quickly go through it. Write the equation of the line graph below in slope-intercept form. Note, we do not see a clear y-intercept. It's not on the 4, it's not on the 5, it's somewhere in between. So we know we're going to have to use our long formula, our slope, our point slope formula. So here we go. Let's go ahead and find 2 corner points. There's one, there's lots of them. So our slope is going to be down 1 over 2, or you can think of it as up 1 over 2. Either way, our slope is 1 over 2, except for, wait a minute, let's double check. Write your name on the line. It's going downhill, so that is a negative 1/2. And then we can use any of these points. We could use 1, 4, or we could use 3, 3, or we could use 5, 2. Let's go ahead and use 5, 2. Remember that when you name a point, you're doing the x first and the y second. It's the opposite of finding a slope. Slope is rise over run, so we always are looking at the y's first, then the x's. But a point, we look for how far do we go on the x-axis and how far do we go on the y-axis. So 5, 2 is my point that I'm going to use. I'm going to go ahead and plug it all in. I'm going to go ahead and distribute. Please remember to distribute the second time. Negative 1/2 times negative 5. That would be 5/2, or we could write it as 2.5, right? 2.5. And then when we go ahead and put it all together, we've got 4.5, which looks believable. That does look like it has the y-intercept of 4.5. If you look at it and just guess that it's 4.5 and you go straight to the equation, you will not get credit for this problem. You need to make sure that you show your work. Anyone could kind of guess that that's 4.5 and use it as a shortcut, but that's not okay. One other thing, oh my gosh, look what I did. I did what my students do a lot. I had the negative up here, and when I wrote it real quickly, I did not put it down here. Please remember to not leave your sign behind. Okay, you got to keep your sign with you. All right, so we're looking at the same problem, right? We don't have an exact, gosh, this looks a lot like our last one, but it was at 4.5. So it looks like it's probably going to be 3.5, but let's just go ahead and see. Once again, we can't just jump to, oh, it's 3.5. We have to see what it is. Let's see, there's a corner point. There's a corner point. So when we do our slope, 1, 2, up. Then we're going 3 up, 1, 2, 3, and 1, 2, 3, 4. So we're going, our rise is 3, our run is 4. But once again, if I sign my name on this, I'm going downhill, so it is negative. And since I can't see what my y-intercept is exactly, we know that we're going to have to use the long formula. And that means we're going to pick a point. So let's focus on a point. We already have one here. We've got 2, 2. Do you want to use 2, 2? That sounds good. Good to me. What do ballerinas wear? 2, 2s? 2, 2? All right. So now we're just going to start plugging everybody in and distributing and gathering like terms. So I'll plug everybody in. start distributing. That's going to cancel out my 2 on the, so what, I'm going to have a plus 1.5. So I've got y equals negative 3/4. Let me scooch up a little bit. Negative 3/4 x plus 3.5. Does that look right? Yep, it looks like 3.5. And another problem done. All right, equations of a line from data. So now we're going to see some written information, and we need to find the equation of a line from it. So here we're telling us our slope is negative 2. There's my point, as if we haven't gotten enough practice with this, right? That's the cool thing, though. All this practice we've been doing is really going to help us do well on the test. So we're going to use the long formula. We're going to plug everybody in. And we'll have y equals negative 2, x minus 3. I could write a plus negative 5, but I'll write a minus 5. It's the same thing. And here I go distributing. Negative 2 times x is negative 2x. Negative 2 times negative 3. See how that has that minus sign? Sometimes I'll say x minus 3 when I'm writing it, but really that 3 is a negative. So when we distribute negative 2 times negative 3, we get a positive 6. Sometimes people forget that, and then they get the whole problem wrong. We're going to gather our like terms. So negative 2x, 6 minus 5 is 1. And there we go. Okay, write an equation of the line in slope-intercept form that passes through. Okay, they give us 2 points. And in class, when they gave us 2 points, I showed you the quick way to find the slope is to put the points in an XY table. So 2, 1 goes in there, 6, 7 goes in there. We're going to go ahead and find the slope. 7 minus 1 is 6. 6 minus 2 is 4. So we go ahead and say the slope is 6 over 4. You could use that, or you could reduce to 3/2. I'm going to go ahead and use 3/2. And then I'm going to pick a point, either 2, 1 or 6, 7. I think 2, 1 looks a little easier. I'm going to go with 2, 1. So once again, there's this formula. By now we all have it memorized. And we start plugging things in, the 3/2, the 2, the 1. Even if you picked the other point, 6, 7, we'll end up with the same answer, which is very cool. All right, so the slope is 3/2. You can still be using 6/4, so we'll end up with the same answer. I'll put the 2 in there, plus 1. I'll go ahead and distribute. Let's see, that's going to be minus 3 plus 1. So we're going to scooch down just a bit, and we get y equals 3/2 x minus 2. So if you wrote y equals 6/4 x minus 2, that's correct. If you wrote y equals 1.5 x minus 2, that's also correct. Okay, number 8, write an equation of the line that passes through the points 5, 4, and negative 2, 4. Warning, warning, alert, alert. Look, this is a gift. In this point, our y is equal to 4. In this point, our y is equal to 4. What do you think the name of the equation of the line that goes to these 2 points are? Or these 2 points is? The name of the line is y equals 4. Every single point on the line y equals 4 has the y value equal to 4. Okay, write an equation of the line that passes through those points. Darn it, there's no alert, alert, warning, warning. We actually have to go ahead and put them in an XY table. So we'll have negative 3, negative 4, and 2, 7. We'll go ahead and find the slope. 7 minus a negative 4 is 11, and 2 minus a negative 3 is 5. So, oh, that's a beautiful slope, right? 11 over 2. Let's pick a point. I'm certainly not going to pick negative 3, negative 4. I'm going to pick 2, 7, because that's easier to work with. And I'm going to go ahead and just plug them in now, because we all know the formula. No need for me to write it out. And we're going to distribute. So we have 11/2 times x, which is 11/2 x. 11/2 times negative 2, which is just negative 11. And then we bring down the plus 7. And we gather our like terms. So we get 11/2 x minus 4. There you have it. Okay, number 10, we're looking at a table that's lying down. If you see a table that's lying down like this, please remember, input is X and output is Y. So we're going to do our hoops. We'll do 13 minus 10 is 3, 5 minus 4 is 1. We already know, just from one set of hoops, that our slope is the change in Y, so the Y over the X. We already know that our slope is 3 over 1, which is just plain old 3. We're not going to use 3 over 1. We could stop there. The reason why we usually do more than one pair of hoops is just to make sure we didn't make a mistake. 10 minus 7 is 3. 4 minus 3 is 1. Yep, there we go again. Our slope is 3. When we were doing our first unit, we were given tables that might not have been linear. So we had to do all the hoops to make sure it was linear and it had the same slope all the way through. But in this test, every table you see is going to represent a linear equation. So you really only need to do one, possibly two hoops at a time. So let's see, what point do we want to pick? We could pick 1, 1. That looks like a great point. So our slope is 3. Our point is 1, 1. We'll go ahead and start plugging everything into our long formula. This one's not bad. We'll distribute the 3. So y equals 3x. 3 times negative 1 is negative 3 plus 1. We'll get y equals 3x minus 2. All right. Next one, write the equation of the line that represents the data from the following table. Okay, this is a perfect one, but if we're very, very careful, we'll be fine with just doing one set of hoops. So here we go. 1/4 minus 1 is going to give me negative 3/4. And 6 minus 4 is going to give me a 2. And if in my calculator I put negative 3/4 as a fraction, and then I do the division sign, and then I do 2, it's going to give me negative 3/8, or it's going to give me what's negative 3/8 as a decimal. I'm not sure, but you can use either one. I don't have a calculator in front of me, so I'm just going to use negative 3/8. And that's all I have to do. All these messy other ones, let's just stop. We took our time. We know that the slope is always going to be, if we keep hooping, it should be negative 3/8. And then we're going to pick a point. What point do you think we should use? Wow, one really stands out, right? This point 4, 1, we're going to use it because it's the prettiest. All right, it's not the prettiest. I mean, fractions are pretty, but it is the easiest one to work with. So then we're going to go ahead. We're going to plug in, when we use our formula, we're going to plug in negative 3/8 for our slope, and then we'll plug in 4 for our h and 1 for our k, and we'll have fun distributing. So we'll have negative 3/8x, and then we'll distribute that. That's going to be positive 12 over 8. I'm going to be doing it a little bit different because I don't have a calculator. I'm going to switch my 1 into 8 over 8, but have no fear, just use your calculator. You can change negative 3/8 to a decimal, that's fine, that'll be correct. And then what I'll have 20 over 8, which reduces to 10 over 4. Probably put that as a decimal, probably a 2.5, which is great. Once again, don't freak, because my answer is in fraction form and yours is in decimals. You could see if you divided 10, if you put in your calculator 10 divided by 4, you would get a 2.5. And then negative 3 divided by 8, if I had a calculator, I would know what you got. Fractions or decimals, both of them are correct. All right, I'm going to check on the time real quick. Okay, 13 minutes. And here we are on equation of perpendicular and parallel lines. I'm going to tell you a secret. We prepared a lot for both parallel and perpendicular lines, but only parallel lines will be on your test. So for the sake of making this video a little bit shorter, we're just going to go over the parallel lines. We've worked on perpendicular a lot. Let's just focus on what we know is going to be on the test. So it says write a line that's parallel to y equals 1/4 x and has a y-intercept of 3. So we know what we do. We find the slope. We always wrote down our old line, and we steal the slope from the old line, and we use it for our new line. So our new line slope is going to be 1/4. And then what do we do when we're done? We are done with the old line. We never look back at it, because that's when we get confused if we do. And our new line also has a y-intercept of 3. So our new line has a slope of 1/4 and the y-intercept of 3. We put it together into the slope-intercept form, y equals mx plus b, and we get y equals 1/4 x plus 3. That is really nice. Okay, the next one, we're given a line, and it's not a really pretty form. We could go ahead, if we wanted to make it look more like what we're used to, we could add the 2 to both sides, and we could get y equals 4 times x plus 3 plus 2. We recognize this as, with the h's and the k's, and we know that this number is the slope. So you could have even known this number is the slope even before we added the 2 to both sides. You do not need to add the 2 to both sides. You can recognize that 4 is a slope. So once again, this is our old line that they're giving us. We're going to steal the slope. No matter which form you did it, we're going to steal it, and we're going to use it for our new line. So the slope of the new line is 4, and then also on the new line is the 0.45. So we know, even though this is in a different section, we are still using the same equation over and over again. We are using the long equation. We also call it the point slope equation. So we're going to plug in 4 for m. We're going to plug in 4 for h and 5 for k. We're going to distribute, so we'll get 4x. 4 times -4 is -16. We'll bring down the plus 5, and we will gather our like terms. We've got y equals 4x minus 11. Sounds good, doesn't it? Okay, given the line y equals 0 and a point, now this one I always tell you, with these y equals 0s or x equals 0s, sometimes it's just easier to draw the graph. So we know y equal any number is going to be just a flat line. But y equals 0 means go to the y-axis, find where y is 0, and then draw your horizontal, your flat line. So there's our old line, and we want to find a new line that's parallel to this old line, and also goes to the point -9,5. So -9,5, once again, when we see a point, our x is the -9 and our y is the 5. It's the opposite of what we think about when we think about slope. So we're going to go -9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 5, 1, 2, 3, 4, 5. So our point is from the origin, -9, and then up 5. There's our point. So we've got to find a line, a new line, that's parallel to the old line that also goes through this point. And when we do that, we see that we have the line y equals 5. That's our answer. Okay, now we moved on to the perpendicular, which we are not going to do the perpendicular, so we are good to go with that. We're skipping the perpendicular, and we're skipping the perpendicular. That was good. That bought us some time. All right, equation of a line from context. There are 4 times as many teens as adults at the mall. I think that's pretty accurate. Okay, complete the table with possible combinations of adults and teens and write an equation that represents all the possible combinations. Okay, so if there's 1 adult at the mall, okay, that would be a slow mall, but then there would be 4 teens at the mall, right? If there are 2 adults at the mall, there are 8 teens at the mall. If there are 3 adults at the mall, 12, 4 adults, 16. Now you could have more fun than this. You could put if there's 100 adults at the mall, there's 400 teens, just whatever you do, make sure you're following this 4 times pattern and fill in your table. Then what you're going to do is, yes, there's a shortcut, but I'm going to do it the longer way so it makes sense for everybody. We would find the slope. So 16 minus 12 is 4, and we know that's going to be 1, and that's going to be 4. Once again, this is a linear table, so we really didn't have to do all of these, but we know that the slope equals 4. And if we go ahead and pick a point, we can pick 1, 4 if we'd like, and we're going to plug it into our slope intercept. Nope, sorry, our point slope form, where we see the slope, we know it's 4, We see H, we know it's 1, and K, we know it's 4. We could have picked any other point besides 1, 4, and we still are going to end up with the same answer. We're going to distribute. So 4 times x is 4x. 4 times negative 1 is negative 4. Oh, isn't that nice? Negative 4 plus 4 cancels out, so we end up with y equals 4x. Some of you, after you make the table, can go straight to this y equals 4x, and that's okay. We're in a context problem where it makes intuitive sense that that would be our equation. So if you want to do that shortcut and go straight there, if you see a problem like this, be my guest. Okay, Juan is going to the mall. Okay, there's lots of mall talk right now. I didn't realize that. And wants to eat lunch. A slice of pizza costs $5 and a cheeseburger costs $2. Write an equation that represents the possible combinations of how many of each he can buy for $20. So this is one of those where in class we would make squares and we'd say, okay, we know Juan is going to buy some pizza and, which means plus, and some cheeseburger. Okay. He's going to buy some cheeseburgers, and altogether, he's got $20. He's going to try to spend all of that on his food. So here we go. A slice of pizza costs $5. So 2 slices would cost $10. 3 slices, $15. That's right. We figured that out because no matter how many pizzas we order, we're going to go ahead and multiply how many slices of pizza we order. We're going to multiply 5 times how many. Now you could use 5x. I'm just using 5p because why not? It's a little fun. And then cheeseburgers cost $2. So he buys 1, it's $2. 2, it's $4. 3, it's $6. So if we don't really know how many he's going to buy, but we know for every one it's going to cost $2. Guess what? We are done. Ta-da! All right, 21. A plant grows at a rate of 0.25 feet per year, and after 3 years, it is 4 feet high. Write an equation that represents the relationship of the total height of the tree and the number of years. Okay, here we go. When they told us we had a rate, that's our rate of change. That's our slope. So our slope is 0.25. And then look what they gave us. After 3 years, it is 4 feet high. These two things go together. In 3 years, the plant will be 4 feet high. So when you see two numbers that are related like this, you know that they've given us a point. So now we get out of the problem. We got our information from the problem. We get out of the problem, and we're going to plug it all into, that's right, into the equation that we can even say in our dream, in our sleep. I don't know if you're dreaming about this, but we could say it half awake. So here we go. We're going to start plugging in our m and our h and our k. So we're going to have 0.25 x minus 3 plus 4. Here we go. Let's start distributing. We'll get 0.25x and negative 0.75. And then we bring down the plus 4. And our very last thing we're going to do is combine our two terms, our two like terms, and we'll end up with a what? Plus 3.25. Does that sound good? Okay, sounds really good. So here we go. 22, if it costs $150 for a 3-month membership in the cooking club and $200 for a 4-month membership, write an equation that represents the relationship between months and the total cost at the gym. So here we go. Once again, we talked about in class that time is independent. And when you're in your science classes, time is always an IV. It's never a DV because time is dependent on nothing. It just keeps going. So let's see. If we're gonna say our time is our independent, that's another way of saying time is going to be x, right? Because x is the independent, y is the dependent, x is the input, y is the output. So here we go. Instead of writing 150, 3, we're going to write 3, 150, which makes sense when you think about it. 3 months of a membership in the cooking club cost $150. And so same thing with this. Instead of writing 200, 4, we're going to say 4-month membership in the cooking club costs $200. So be careful when you see problems where they give you information, but they're not really setting it up where the x is coming first. Stop and think. Time is always independent. Usually money is always dependent. I'm sure we could come up with a problem where money would be independent, but usually it's dependent. All right, so we've got 2 points, and we know in class we take 2 points, we put them in our XY table, because that's our easy way of finding the slope. So 200 minus 150 is 50. 4 minus 3 is 1. So we know that our slope is y over x. So it's 50 over 1, but I'm just going to write 50. Doesn't matter which point I pick. You know what? I'm going to pick the 4 200. I'll just shake it up a little bit. So, yep, we're going to use this formula again. We're going to plug in the slope, plug in the h, plug in the k. So we've got y equals 50 times x minus 4 plus 200. And we're going to go ahead and distribute. 50 times x is 50x. 50 times negative 4 is negative 200. Oh, that's nice. That's fun. So when we gather our like terms, we see that negative 200 plus 200 is gone. It's 0. So our equation is y equals 50x. Okay. So when we look at that, I guess that would make sense looking back at the problem. And if I had more time on this video, it'd be fun to just talk the answer through. But the answer definitely makes sense. You may want to think about that, why it makes sense. And yay, down to our last, with 26 minutes in, we're down to our last section, lines of best fit. And so this scatter plot represents the amount of money a snow plower makes depending on the temperature. So that looks good, right? Higher temperature, I guess. More snow, less ice. I'm not sure really what we can interpret or what we can analyze from this. All right, so let's look at this. I want to draw a line that goes through some corner points. So when I'm looking here, I might draw a line. Let me see if I can just freehand one. I might draw a line like this. Doesn't look very straight, does it? And that looks like a pretty good line of best fit. But the problem is I didn't draw one that went through any corner points. Nope, I mean, not even this one. So that's not a corner point. That's not a corner point. That's not a corner point. Okay, so not a good job. So what I'm going to have to do is if I had a ruler, what I would do is hold my ruler over and then try to not only include all of these, the general direction of the cluster of data points, but I would want to include some corner points. So as I'm looking, if I'm looking this way, maybe I could use this guy as a corner point. Let's see if I, how about this guy too as a corner point? So I'm not going to use any of the points that are given, mainly because there are no corner points. And I'm going to go ahead and connect these 2 corner points. And look how nicely that worked out. It's a nice looking line of best fit. I think it represents the data points well. And so most importantly, I have this point and this point that are corner points. And so just like we did in class, because this is such a wonky table with the x-axis going up by 2 and the y-axis going up by 100, we're going to go ahead and just make a table and find our slope that way. So I look at this point, and the point's name is 16 because the x value comes first for the point, and 300 for the y value. So I'm going to put that in my table. And then this second point, its name is 22 for its x value and 500 for its y. So I'm going to also put that in the table. And I'm going to go ahead and find my slope this way. So I'll go ahead and do 500 minus 300 is 200. And 22 minus 16 is 6. Yes? Okay. So you could, if you had a calculator, which I'm really regretting not bringing a calculator up to the front where I'm making the video, we could say our slope is 200 over 6. We could reduce it to 100 over 3, or I guess we could change it to, would that be 33.3? I'm going to go ahead and keep it in fractional form. It doesn't matter if you change it to a decimal, okay? So my slope is that, and now I'm going to go ahead and pick a point. Either point will do. I guess we could do the, oh, it's going to be a mess without a calculator. I may have to pause and and get a calculator and do this. So let's see, I'll set it up. Y equals 100 over 3 times x minus 22 plus 500. So let's scooch this down a little bit. I'll get y equals 100 over 3x because I'm distributing. And then I'm going to have to get a calculator, aren't I? 2200 over 3 plus 500. So hold on, I'm going to pause this and get a calculator, and I will be right